All right, so these are going to be the odd numbers for your exam review. And there's another video that's for the even numbers. So write out the first 5 terms of the sequence. If I look at number 1, believe it or not, this is an arithmetic sequence because it's linear, so that might be helpful. If I plug in 1, 2 times 1, take away 1 is 1, and then times 2, the first term is 2. If you see it as arithmetic, do you know what the common difference is? Can you visualize that and see it in the equation? And the answer would be, do you know what the slope is? Do you know what m equals in this linear one? And then when you look at it, the only way you can see m is by multiplying, right? 2 times 2 is 4. So the common difference is actually 4. So the first 5 terms, in this case, because you recognize, that's not adding 4, is it? Let's try one more time. So, if you recognize it as arithmetic, that's awesome, right? As soon as you know the slope, it's over. If you didn't, you'd plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. All right, number 3. The given pattern continues. Write the explicit rule for the sequence. So in number 3, negative 2 to 2, 2 to 6, 6 to 10, 10 to 14. Dang, it looks pretty close to what we even just did. This is an arithmetic sequence. Why? Because the common difference is 4. What is an explicit rule for this? It would be an for n minus 1 minus 2. You could also take another term like n minus 2 plus 2 or n minus 3 plus 6, and it's done. Number 5. The number of students in a school year, n, is estimated by this model about how many students are in the school in each of the first 3 years. So in each of the first 3 years, you'd first plug in 1. I'm going to use a calculator, just because that's the mood I'm in. So if I use a calculator and plug in 1, let's see what answer I get. So I get 1,020. If I plug in 2, let's see what I get. I get 2,360. Did I do that right? If I didn't do that right. Here, plug in 2. I get 20 plus 28 plus 83. I get 1,310. Plug in one more time. So plug in 3. And I get 1,700. Number 7. A sequence is defined recursively. Write the first 4 terms. Here, what do you do with the term before? Is you multiply it times 4. So the first term is 6 times 4. Let's see how far I can get. 80 and 60, 96. Can I do it one more time for fun? I don't feel like it. 96 times 4, 384. Here it's defined recursively. I'm given 2 and 5, and then it says 2 terms before, which is 2, and then subtract 3 times the term before it. So in other words, you're going to go 2, take away 3 times 5. So again, what am I doing? 2, take away 3 times 5. Can we put that together in our head? 2 take away 15 is negative 13. We got to follow the pattern again for one more time. So this is going to be 5 take away 3 times negative 13. Well, 3 times 13 is 39, and when you subtract a negative, you're really adding. So it's going to be 39 plus 5, which is 44. So when something's defined recursively, can you follow the pattern to find the terms that you need? Number 11. Here's a situation where we don't have a formula to be able to add the series. Instead, we have to expand and then use our calculator. We just got to go one at a time. So how do I find the first term that we're adding? We plug in 0. And if I plug in 0, the number is 1 over 5. The next number I'm going to plug in is 1. And 1 plus 1 is 2. So it's 1 over 25. One more time. No, another time. 2 would be 1 over 125. 3 is where we'll stop. That's 1 over 625. So it's a good question. When I plug in 0, I'm doing that. So when I plug in 0, 0 plus 1 is, and then 5 to the 1 is, so that's what gives me 1 over 5. When I plug in 1, that plus 1 is in the exponent. Right? You see how it's raised up compared to the 5? So I'm calculating the exponent, then going and then finishing it. And there's a pattern. It's like 5 to the 1, 5 to the 2, 5 to the 3, 5 to the 4. The numerator stays the same. But I'm not done yet. I got to use my calculator. Can you add it up? So 1 over 5 plus 1 over 25 plus 1 over 125 plus 1 over 625. And the exact answer here is 156 over 625. So when you're ready, turn the page. Number 13. So here's an example that's not arithmetic and it's not geometric. It's a unique rule that I have to expand and then add. Number 13. Is number 13 a unique sequence, or is it arithmetic or geometric? 3 plus 6 plus 9 and so on to 18. So why? Because there's a common difference. What do I need to know for the formula? I need to know the first term. I need to know the last term. And I need to know how many terms are there. So of those three, what don't I know that I need to solve for first is n. How am I going to do it? I'm going to write down a rule for this sequence. And the rule I'm going to write down is 3, n minus 1 plus 3. And then after I write down the rule, an is 18. And then I'm going to solve for n. So I write down the rule. I plug in 18. I need to know what term number that is. That will tell me how many terms there are. So how am I going to solve this? Subtract 3 and you got 15. Divide by 3 and you have 5. Add 1 and how many terms are in this sequence? 6. Now can I write down the formula? So to add the first 6, it's 6 divided by 2. A1 plus an. And there it is. So that's what you're going to calculate. So that's 21 times 3. So the sum of that sequence is 63. So sometimes you have to find what you need for the formula, then you can finally use the formula. All right, number 15. Can you find the 9th term of this sequence? So it's arithmetic, because there's a common difference of 3. The rule for this would simply be 3 n minus 1 plus 0. I don't need the plus 0 at the end. What term am I looking for? The 9th term, and then you have your answer. So the 9th term in this sequence is 24. Am I caught up to you now? You know all that time you had? Are you at 17? No? All right, try number 17. Can you find, if I give you any two terms in an arithmetic sequence, can you tell me the rule, and can you tell me the arithmetic means between the terms given? So we're going to do number 17, the odd numbers right now. This, do you remember how to find the common difference for arithmetic? It's the slope formula, right? y2 minus y1. So in this case, that would be negative 110 subtract negative 54. What would the denominator be? Like the x's would just be 16 take away 9. So you can use your calculator. When you subtract a negative, you're adding. So it's negative 110 plus 54. So I think this is negative 56 over 7. Does that go in evenly? Yeah. So the common difference is negative 8. So first, what's the rule then? So see, can you write down the rule? And then find the means in between using negative 8. So what would the rule be? Negative 8. Do I need to find the first term for the rule? No. I can use any one, right? So if I use the 9th one, what am I going to write down? N minus 9 and then negative 54. That's a rule. And then how do I find the means? Well, I start at, what's negative 54 take away 8? Take away 8, take away 8, take away 8. That's 80. And then where do I stop? Take away 8. I got to do a few of these. And then you would end at negative 102. What's the good news? If you subtracted 8 again, it would equal negative 110, means it fits, right? So that in the box are called the means, right? In between the numbers you know, the terms that you know. All right, I'm going to slow down for a moment here. I want you to try 19 and 21. Some of you know this, like it's like clicking, and some of you just need to practice with the formulas. I know, I felt it in my nose. I felt like Rudolph or something, right? Just feeling on the tip of your nose as well. So obviously what I don't want you to do is go 2 plus 4 plus 6 plus 8 plus 10 plus 12, you know, that would be awful, right? Up to 336. Are you clear that it's arithmetic? Why? Because there's a common difference of, are you clear what the formula is to add up an arithmetic? Have we practiced it enough? There's one thing I don't know that I need to know. Do you know what I don't know yet of that series? I don't know how many, correct? So let's just go to it right away. How am I going to find out how many? I need which number is going to help me find out how many terms there are. 336. What's the common difference? 2. I'll answer it. And then if I go n minus 1 plus 2, right? That's the rule. Just plug it in 336. Can you solve for n? So subtract 2, and you get 334. Divide by 2, and that's what? 150, 167? Is that right? Say yes. Yes? Or am I wrong? I'm just doing it in my head. 167? And then add 1, and it's 168? Is that how many terms you got? So then when you add it up, 168 divided by 2, and it's 2 plus 336. So put that together. I got 28,392. Can anyone confirm they got that too? All right. Okay, try number 21. I'm going to give you a moment again. Are you comfortable with sigma? Are you comfortable with some notation? The first thing you need to know, and on your exam tomorrow, you're not going to be told it's geometric or arithmetic for most of them. Like, you're going to have to recognize it. So do you recognize this rule? What type of rule is this? Linear. Because it's linear, right? That means it's arithmetic. So you need to know what three things do I need to write down. Then I can use the formula. So try. So, would you agree A1 is -3? What, the last term, I'm going to plug in 50. 200, take away 7. Is that 193? And then how many terms do I have? 1 through 50 is just 50. Now use the formula. So 50 divided by 2, -3 plus 193, and there you go. So that's 4,750. All right, turn the page. These are the ones you really need to focus on, the stories. So, can you read 23 annotated? Do you understand that as a geometric story or an arithmetic story? Is this a story of a sequence or a story of a series? So, break it down, unpack it. Like, do a lot of work on it. Thank you. I'm impressed. I see your sheet. Thank you. I'll print it out. So, let's see where we're at. Evelyn, is this arithmetic or geometric? Why? I like it. Do you think I should write down +4 or -4? I agree. Now, when I look at this, Nancy, is this a situation where it's a sequence or is this a situation of a series? Are you guessing? Like, are you sure or unsure of it? So the question is how many bricks are required, right, to build the staircase. So if I want to know how many bricks I need, would that be a situation where I have to add each step to figure out the number of bricks? Or do I just need to know like how many bricks are there in whatever step I'm looking at? So I want to know how many bricks are in the last step, or how many bricks in total for the staircase. How many bricks are required to build the staircase? So that would be a series. Awesome. So for a series, I need to know a few things. I need to know how many bricks are there in the first step. In the bottom is the first one. That's 103. What else do I know? Is there how many steps are there? So what don't I know that I need to solve for? Okay, so if you haven't done so, can you tell me and find out how many bricks are in the last row? The 16th row, how many bricks? So what number should I start with? -4. My n is 16, and then how many bricks were in the first row again? 103. All right, solve it. How many bricks are in the last one? I'll do it too. I got 43 bricks on the 16th step. Did you get that by the time you get to the 16th step? So then how many bricks do you need in total? So can you do this formula, add up all the bricks, all 16 steps, and then use your calculator. One more. You can come here. There's one more. So I'm going to go 16 divided by 2. 103 plus 43. Did you get 1,161? So you need 1,161 bricks. Huh? 1,168, right? Did I say it differently out loud? 1,168 bricks to what? To build the staircase. All right, number 25. I need you to read it. All right. I need you to recognize, is this an arithmetic or geometric story? I need you to recognize, is this requiring a sum of adding them all or just a sequence that you're looking at? And then use your calculator. So a theater has 22 seats in the first row, 21 rows in all. So already I know A1 equals 22 and N is 21. Each successive row contains 3 additional seats. So if I'm adding 3 every time, that's arithmetic. How many seats are in the theater? So if I want to know how many seats there are, is that a sequence or a series? And the answer is it is a series, right? You're adding it up. There's one thing I don't know that I need to know. And what I don't know is how many seats are in the last row. So in row 21, how many seats are there? And how do I find it? So the common difference is 3. 21 is my n. And then I go subtract 1 plus 22. So I use the arithmetic rule and plug in 21 and then solve it. Then I can use the sum formula. So that's 3 times 20 plus 22. So there are 82 seats in the last row. So if I want to now figure out how many there are, hey Jose, what's the other thing you're doing? Is it good? Oh, is it like legit? Like, you know, something you have to communicate. No, just whatever, waiting. You can go to 27, 29, 31, right? So to add up all the rows, that's 21. So it's 21 divided by 2. We have 22 seats in the first row and 82 seats in the last row. So that's 11. No, it's not 11. 10.5. $104. Did you get 1,092? All right, on to 27 and 29. So write an explicit rule for the sequence below, then find the 12th term in the sequence. So first thing you need to ask yourself is this an arithmetic or a geometric sequence? Can you see that we're not adding whatever? And one of the indicators is positive, negative, right? So how am I going to find the common ratio? What am I going to do? Right, and whatever you want, any two consecutive terms will find it. But you can do the first two and divide. So negative 3/4 divided by 3. And what do you get as the common ratio? It doesn't work. It's negative 1 over 4. And again, you can find that by going 3/4 divided by 3. When you divide by 3, that means the same as times third, right? Times the reciprocal. And you can see it's negative 1/4. I'm asked then to find a rule. So what would the rule then be? The explicit rule for this. First term is 3, then negative 1/4, and then what's the exponent? N minus 1. And then which term am I looking for? The 12th. So see if you can find the 12th term. So it's a very small number. Number 29. So I want you to read the story for 29, annotate it, and then understand, is this a geometric story or an arithmetic story? Is it a sequence story or is this a series story? So a particular substance decays in such a way that it loses half its weight each day. How much of the substance is left after 10 days if it starts out with 256 grams? So this is a geometric story where the common ratio is 1/2. The first term is 256. 56, and I'm not adding it up, it's a sequence. I want to find the 10th term. So to find the 10th term in the sequence, we started with 256, 1/2, and then the exponent would be 10 minus 1. And if you did the work, how much of the substance is left? So after 10 days, 1/2 gram is left. All right, when you're ready, turn the page, 31. So number 31, break it down, unpack it. So annotate it. Is this a geometric story, an arithmetic story? Is it a sequence story? Is it a sum story? Pendulum bob. Do you know what that is? Feels like you named something, right? Bob. So a pendulum has some type of stick of some sort where it's going back and forth. The bob is the bottom part that gives it weight. It goes back and forth. So usually it looks like maybe a ball or something at the bottom. So a pendulum, so some kind of a stick with a ball at the end going back and forth, swings through an arc of 50 inches. So if you trace its path on the swing, the first swing is 50 inches. It slows down. Every swing after that is only what? 86%. That's an indicator it's a geometric one. Geometric means you multiply. How do you find the percent of something? You multiply by the decimal, right? So the percent is a decimal. That's a good indicator to know it's geometric. What's the length of the arc after 11 swings? Is that a series? Are we adding that up? Or do we want to find the 11th term? Right? So, understand what you're looking for. So, in this situation, A1 is 50. The common ratio is 0.86. So, the percent is a decimal. So, the rule would be 50.86 to the exponent n minus 1. And if we just want the length of the 11th swing, the number we plug in is 11. It's not a sum question. It's just the 11th term. And it says to 2 decimal places. So to 2 decimal places, I get 11.06. So the length of the 11th swing is 11.06 inches. 33. So let's read 33. Can you unpack it? Annotate it. Is number 33 geometric or arithmetic? You can expect on your exam that these stories will all be mixed up. That you're going to have to be a good reader to know, is it geometric or arithmetic? Is it a sequence or series and so on? Marina takes a job with a starting salary of $39,000. That's nice, right? And her salary increases by 5.5%. So why is this an indicator that I already know what type of situation we have? This is a geometric, right? And then it says, what is Marina's salary in the 6th year? Is that a sequence? Or am I adding up the salaries every year? In which term am I looking for in the sequence? Right? So you know the only tricky part here is to understand what R equals. So you know that 5.5% as a decimal is 0.055. But if I use that as a ratio, all I'm looking at is the increase. I'm not looking at her full salary. So 5.5% is just her raise, not her salary and her raise together. So how do I put it together? The salary and the raise together in one number? What number do I put in front? 1. All right. So if I can understand that, I want to find the 6th term. We started with 39,000. The common ratio is going to be 1.055. That 1 in front means her salary is included with her raise. And then the exponent would be 6 subtract 1, and that's what you put in your calculator. So to the nearest dollar, it would be 50,971. All right, 35. Can you find the sum with sigma? So number 35. And for 35 it might be, do you know how to type it in your calculator, right? It's a little bit challenging with parentheses to be able to type in the formula in your calculator. So what's the indicator that I know it's geometric? Is that it's exponential, right? It's not linear. So what do I need to know for a geometric series? Well, I need to know the first term. What happens when you plug in 1? 1 take away 1 is 0. Anything to the 0 is 1, and 1 times a third means A1 is 1/3. Now the formula. What number should I start with now? 1 take away, you have to use parentheses. So -3 parentheses to the exponent. How many terms do I have? 13. And then the denominator is 1 subtract -3. So type that in. And the exact answer is 398,500 81 divided by 3. All right, turn the page when you're ready. 37. I know it's a challenge to type it in your calculator. Just the more you practice, the better you get with parentheses to type it in correctly. So our next one is 37. So as Suni improves her algebra skills, she takes 0.8 times as long to complete each homework assignment as she took to complete the preceding assignment. So what's an indicator that I already know it's geometric? What word did I just look at? Times, right. So if it took her how long for the first assignment? 60 minutes. How long will it take her to complete the fifth assignment? So just that question is a sequence. Find the total time she took for her first 5 homeworks. That now is a series. So there's a sequence and a series question. So let's break that down. So first of all, how long did it take to complete the fifth assignment? So if I just want the fifth assignment, A1, it took 60 minutes. Her R is 0.8, and then to the exponent, 5 take away 1. So simple geometric. And if you round to the nearest minute, it would be about 25 minutes. If you round to the nearest minute, I get 24.576 to the nearest minute. What would if I wanted to add up the first 5? Could you set that up to add the first 5? So what was the total amount of time she took on her homework? So it would be 60, and then what would go inside the parentheses? 1 subtract 0.8 to the 5, and then the denominator would be 1 subtract 0.8. So again, use your calculator. Probably. So to the nearest minute, how long did it take to do all her homeworks? The first 5 is 202 minutes. So, the fifth assignment took 25 minutes to complete. The total time for the first 5 assignments is 202 minutes. All right, 39. Again, unpack number 39. Do you see why it's geometric? Do you know how to set it up? Is it a sequence or series? And so on. Joytown has a population of 40,000. That certainly looks like A1. The population is increasing by how much? 2.5%. So here's another situation. If I go 2.5%, that's 0.025, correct? Do I need a 1 in front in this situation? Yes or no? Because 0.025 is only the increase, not the population and the increase. It needs both. N. That's actually, I don't know N. That's the how long it will take, right? And then, what am I looking for? My AN is actually the double. So if I double it, how much population is doubled? So now could you set this up? And once you set it up, you're going to use your calculator to solve it. So let's see the setup and then use your calculator. So the formula we know is this, right, for geometric. So AN is 80,000, 40,000, 1.025, and then that's what I'm solving for. So there's the setup. Now, do you remember how to use the TI-89 or Inspire? Do you know how to solve an equation with it? All right, so let's see how that would look. So the button, I'm going to go F2, and then F2, and then solve. And you're going to type in 80,000 equals 40,000, and then 1.025. Now, I'm going to use X as the variable for my calculator because this is a little easier. But when you put in the exponent, your parentheses need to be in the exponent. So to the exponent, X subtract 1, we need the parentheses around X subtract 1 or it won't work. Then the last thing you need to do is comma X. That tells the calculator to solve it. So I press comma, then X, then close it, and then diamond enter. Approximately how long will it take the population to double? And you can see it would take about 29 years. Yeah, I look at. Is it not working or the battery's not working?
No, it just says isn't like I don't know, but I did not send you the answer.
Oh, because we didn't type it in. So the first thing you need to type in was 80,000 equals.
Oh, okay.
Like we didn't have an equation. You just typed in the right side of the equation. All right, it would take how many years? So if it's growing at 2.5% a year, it would take 29 years to double the population. All right, 41. In number 41, is that a situation of a geometric or arithmetic that I'm adding up? And the answer is it's geometric, and even tells you it's geometric, right? Infinite. How do I add that up to infinity and beyond? How do we do that? So this is a situation to add up. A1 is 3. The denominator is going to be 1 subtract what the ratio is. How do I easily find the common ratio? Divide. And -1 divided by 3 is the easiest way. That's -1/3, and there you go. So you put that in the calculator. It's a much simpler formula than if it wasn't infinite. So it's 9/4, or 2.25. All right, turn the page. Here's the last part of the exam prep, 43. So we got 2 more to do, and then the odd numbers are done. So it'd be wise to look at the odds and then do the evens tonight, so that you're ready for the exam tomorrow. I bet you there's some classes that are giving exams like Thursday or Friday this week. So that's right. So I'm trying to get ahead of all that early. Tuesday. Who does it Tuesday, right? Me. Right? Get ahead of it.
Unexpected.
Unexpected. But good, right? Who wants 4 exams in the same day?
Not me.
No, not me. All right, 43. Back to Bob. So, have you seen the movie What About Bob? It's a good movie. So, Bill Murray, Pendulum Bob swings through an arc of 40 inches. Each swing thereafter, it only goes 70% as far. How far will it swing altogether before coming to a complete stop? Well, this is a situation to infinity. So in this situation, this is like adding all the swings possible, right? Like an infinite number of swings until it stops, where A1 is 40. And what would you say the common ratio is? 70%? 0.7? Done. That's what you put in the calculator. So, here's a situation where you can't have like a decimal swing. It either swings or doesn't, right? So I'm going to round it to a whole number. So about how many swings until it comes to a stop? Do you get 133? All right, one more left. Number 45. So let's finish this off. A ping pong ball is dropped from a height of 9 feet. It always rebounds 1/3 of the distance fallen. Find the total sum of the rebounds, heights of the ball. So if you drop a ball and it keeps going again and again and again and again and again and again and again, add it all up, this is an example of an infinite sum again. So how do I find that sum? A1 would be what number? 9. The common ratio would be 1/3. When is there an infinite sum? When the absolute value of the common ratio is less than 1. So 1/3 is good. If it bounced higher than what you dropped it, right, then it wouldn't be able to add this up. All right. So the total sum of the rebounds is 13.5 feet. Yes? Thomas, are you okay? Do you want me to see your calculator, how you typed it in? I can look at it. But anyways, for me right now, it's GMath over, out, done. All the odd questions are done.